So welcome everybody to today's Condair Outdoor Cooling webinar. Thanks to all of you for showing your interest in registering. It's a pleasure to have you with us for the next hour plus. My name is Peter Rush. I'm with Condair since 17 years, based in Switzerland, and I'm responsible for the Middle East market, coordinating with all our partner and customers and do the best to offer you the best support. And beside me during this webinar, so it looks on the screen, is our specialist for the outdoor cooling. It's Leo Rasmussen. He is the presenter of our today's webinar, and he is a specialist with a many years of experience in outdoor cooling, especially. But before we start, let me offer you some information about the webinar itself. The presentation will take approx 45 minutes, and afterwards we will have roughly 50 minutes plus for questions and answering. On the right side of your screen, you see the go-to webinar control panel, where you will find the audio options to handle the mic and the camera, and as well questions tool. Please use the question section of the go-to webinar control panel to ask the question, of course in writing. And I'll be watching your questions. Some of them I might answer straight away in writing during the sessions, and others, most important ones, most probably we will answer at the end. But of course, you can send questions as well to the indicated email addresses, the ones you will see later when Leo starts his presentation. Then we are offering you as well some docs. Today's presentation slides are available in the handout section of the control panel, along with any other literature that has been uploaded. So please help yourself, loads down, and maybe you can study all this information during a more quiet moment. And 1 hour following the session, you will receive an email with a certificate of attendance from CIBSE, SIPSI, and as well a link to a recording. So this whole webinar will be recorded, and you get access to a video, so you can watch it at a later time again and study more closely. Sorry, I have a little problem here. Sorry for this. Yeah, sorry, I stopped here. The video, take the chance and load down the video to show your colleagues, or as I said, to study further. And just one last information, if the camera, if the presenter's camera is turning off during the slides, mention it so we mention it so we can handle, but normally it's only because he's gone offline, because he turns it off, so don't worry about that. Well, that's it from my side currently. I'll hand over to Leo to start the presentation, and have fun. I hope we will offer you a very interesting hour, and hear you later after the presentation of Leo.
Thank you, Peter, and also a very warm welcome from my side. As Peter mentioned, I have some years of experience, exactly 35 years of experience in the humidification and evaporative cooling industry this year. Me and my wife formed a company back in '98, which became a member of the Condair Group in 2011. And since then, I have been working as a senior advisor for the group, helping with different projects around the world. That can be in evaporative cooling, that can be in special humidification, things like that. And my key focus area is mainly on water treatment and hygiene, plus of course evaporative cooling and all of this. So let's get started. The agenda for today, if I can change, yes. The agenda for today is that we're going to look at outdoor evaporative cooling in hot and dry areas. Few words about Condair. What is adiabatic cooling and how does it work? The impact of local climate data on systems like this. How much cooling is actually needed? How much heat do we need to get rid of? There are unfortunately also some limiting factors for outdoor cooling that we have to be aware of. We will come through this. As we're using water, then we also look a little bit into this, and we will look at some of the risk factors or hazards that we have involved in outdoor cooling. At the end, we will look at the different cooling technologies and also on the energy consumptions for outdoor cooling. How much cooling can we achieve for each kilowatts of electricity that we are supplying? Ending up with a summary, and after that, as Peter mentioned, there will be time for questions and hopefully some answers in the end as well. A few words about Condair. Condair is a family-owned company with a headquarter in Switzerland. We have specialized in humidification, dehumidification, and evaporative cooling systems. We have own sales and service offices in 24 countries and are represented in a lot of countries around. We have more than 50 reps, and along in the US, we have more than 120 agents as well. We have 3 production sites, one in Ottawa up in Canada, and our main production site is in Hamburg in Germany. And then we have a bit of production in Denmark as well, where I'm normally based, and we also have in China. In total, we are more than 800 employees. Our vision is to create healthier built environment and to increase productivity within with optimal humidity for a better life. We focus on health and sustainability. Humidity is also important for health, and also to make buildings sustainable. When we install cooling systems, humidification systems, that also helps with the sustainability of the buildings. What is adiabatic cooling? Adiabatic cooling is not new. It has been used for many years to reduce the ambient temperature in hot and dry areas. Actually, it goes back to 2500 before Christ, where the Egypts started already to use water as coolant by spraying out water on the floors and or in the rooms where the royalties were. So it has a very long history. The most common application nowadays has been in the hospitality industry, in hotels, around restaurants, pool areas, big public places, and so on, to make the climate a bit more human, especially if you are in the hot and dry areas. The cooling effect depends on the local climate. The drier it is, the more cooling we can apply, or we can create. There's a lot of different ways of cooling. It can be from the floor, it can be from the top, or from the sides, whatever. But in general, it's all about evaporating water. It's the same that happens when we take a dip in a swimming pool and we get up, and when we sweat, that helps to cool our body and keeps us cold. Evaporation of water, how does that work? So when water goes from liquid form into vapor form, it absorbs energy, or it needs energy to do so. When we spray it out, it absorbs energy from the surrounding air. The air temperature goes down and the humidity in the air goes up. If we look in psychrometric charts, where we have the temperature here. This is in Celsius. Sorry. And here we have the absolute humidity in terms of grams of water per kilogram of air. And then we have curves for the relative humidity showing here. If we take an example, if we start with an outside condition of 38 degrees C and a relative humidity of 20%, if we start adding or evaporating water into this air, then the temperature will drop down. If we humidify or cool, evaporate water until we reach 60%, our temperature will drop down to 26.5 degree, and the humidity will increase up to 60% relative humidity. And this is by adding 5 grams of water per kilogram of air. When water evaporates, or this process is called an adiabatic process. It follows the enthalpy lines in the psychrometric chart. There's a transformation, there's a reduction in sensible energy, so the energy that we can feel, the dry temperature you can say, and an increase in the latent energy of the air, meaning there's an increase in the absolute humidity in the air. The absolute humidity in this case goes from 8 grams per kilogram up to approximately 13 grams per kilogram. The total energy in the air remains the same. It can be calculated in different ways, but here's a formula for the enthalpy in the air. We will not go too much into detail with that. What you can also see in the psychrometric chart here is the range of human comfort, or the defined comfort zone according to ASHRAE. This goes up to around 27 degrees, and it goes up to 50% at 27, and it goes up to 80% at 23 degrees C. So this is the area that we should try to get as close to as possible in our process when we make evaporative cooling, especially for outdoor. When water goes from liquid form into vapor form, as mentioned, this needs energy, and the amount of energy needed is 2,453 kilojoules per kilogram when the water temperature is 20 degrees C. This evaporation, when it goes from liquids to vapor form, takes place very fast. It takes less than a second if we evaporate the water into 10, 15 micrometer sized particles. If it's clean water, then it's absorbed very fast into the surrounding air, and then we can absorb this amount of energy for every kilogram of water that we evaporate. We can convert from kilojoule per kilogram into kilowatt hours per kilogram, so that for each kilo of water or each liter of water, we have a cooling effect of 0.68 kilowatt hour per liter of water, or per kilogram of water that we can evaporate into the air. It is also seen that the evaporation energy is more or less independent of temperature, whether we have 20 degree warm water or we have 60 degree warm water, the evaporation energy is more or less the same. There's only a difference of 4% between 20 degree warm water and 60 degree warm water. So it's not the energy to heat water, it is the transformation energy from liquid to vapor that gives us our cooling effect. Actually, the energy needed, or the cooling effect we get when we evaporate 1 liter of water is the same as the cooling effect you will get if you melt 7 kilograms of ice. So water is a very effective coolant to use. Yes. And how much cooling is needed outside? Yes, our main heat source in this area is the sun, is radiation from the sun. And that depends on the area where we are and time of the year and time of the day. It can be more than 1000 watts per square meter in direct sun. And if we should absorb all of this energy, we would need to evaporate 1.4 kilogram per square meter of area, which is a very high amount. That's a 1.4 liter per square meter of area if we should absorb all the radiation energy that we get in worst case from the sun. In practice, this is not realistic. So the first message is that it only makes sense to talk outdoor cooling if the area is shaded one way or the other, so that most of the radiation from the sun is eliminated. Of course, we cannot avoid indirect and diffuse radiation that we will have in the area. In practice, we normally calculate with around 250 watts per square meter to be eliminated as the goal for our cooling purposes here. And if we use this, then we can calculate that we would need around 0.4 or 0.37 kilogram per square meter, or 0.37 liter per square meter that we need to evaporate per square meter of area. That is fine. We can, of course, we could easily spray out a lot of water, but how much water can actually be evaporated into 1 cubic meter of air? It is clear that the lower the ambient absolute humidity is, the more water can be added and the more cooling effect can be achieved. If we look at the psychrometrical chart again, take another example, 40 C and 20% relative humidity, and if we moisten this air up to 64% relative by adding 5.6 grams per cubic meter, then our temperature will drop. If we start here and we start evaporating water and we go down here, that is fine. The limits we normally work with is an absolute humidity of around 15 grams per kilogram. If we exceed this, then we are getting too far away from the comfort area and the air becomes heavy and sticky, and this is not comfortable for most people. So as long as we get closer to the comfort area when we make our cooling, then then it works. But if we do not get closer, then it doesn't really help, or it doesn't feel better compared to the start condition. Yes, this was just one example again. So the takeaway is that in average, when we do rough calculations, we calculate with around 5 grams per kilogram of air that we can add, or 5.6 grams per cubic meter of air that we can add to the air. That gives us a good cooling effect. Of course, the amount of water we can add depends on the time of the year, local climates, and all of this. So, but this figure is a rough figure that is that can be used in most cases in dry areas. We can only cool the air once. So once we have evaporated water into the air and we have cooled it down, then we have to wait until it is mixed up with some new, fresh, dry air, so that we can add more water and keep cooling the area. If we take an example again, a cooling system for an area of 200 square meter with a height of 5 meter means us we have a volume of air of 1000 cubic meter with the same design criteria from before, 250 watts per square meter and max 5.6 grams of water we can add. The cooling we would need in a situation like this is we have the area, the radiation underneath. That means we should provide a cooling effect of 50 kilowatts cooling. And to do that, if we should eliminate this 50 kilowatts with water, evaporating water, with a cooling or a cooling effect of 0.667 kilowatt hour per liter or per kilogram, we would need 74.1 kilogram of water per hour to eliminate 250 watts. And how much air is needed to absorb this? If we can add 5.6 grams per cubic meter, we can calculate that to be 13,230 cubic meter per hour. And with our volume of 1000 cubic meter, we can calculate how many air exchanges are needed to do so. That means in this case 13 times per hour. And if we just check our calculations, say we have 13 times per hour times this 5.6 grams that we discussed before, then we come to our figure again. The takeaway here is calculate with around 75 grams of water per cubic meter of air under the shading or in the room or the area where you want to make cooling. This is a ballpoint figure that we are normally using. The limiting factors for outdoor cooling is, of course, the local climate, and it is wind. At Condair, we use climate data which we get from a source called Metronorm. It's a huge database with climate data from cities all around the world. We can get hourly data for radiation, temperature, humidity, wind direction, all of these, raining hours, and so on. So we use these. We can import these climate data into a psychrometrical charts. So each dot you see in this chart here represent 1 hour with this specific climate conditions. If we start with Riyadh as an example, we can see all year round we are well below our design limit here of 15 grams per kilogram. So in all of these hours that we have up here, we are able to provide a good cooling effect. Whereas if we take Dubai with more coastal climate, if we have our limit here again with this 15 grams per kilogram, we see that in all of these hours out here, it doesn't really help much to start cooling. It's a more coastal climate, it's a more humid climate we have there. In some of these hours up here, we can still provide cooling, but it varies from city to city and from place to place. As long as the absolute humidity is below 15 grams per kilogram, and the resulting climate is closer to the comfort area, then it makes sense to talk cooling. If we look at the psychrometrical chart again, then we can illustrate it like this. In this area here, if we have these climate conditions up to here, then it really makes sense. If we get, the closer we get to our limit of 15 grams, heating of the air so that it comes much higher here. But it's simply too humid to give cooling effect, and we are not getting closer to the comfort area, which is always critical. Wind direction and velocity has to be considered. When we atomize water, when we create very small aerosols, they have very little inertia, and they will follow the wind direction. So a wind velocity of a few meters per second will very fast or very quickly will draw away the cooling that we actually provide. So this has to be taken into consideration as well. Maybe you have to shield the area or protect for wind as well when you want to start calculating or to design an outdoor cooling system. You can get this information about typical wind velocity as well from climate databases as well. As we are using water for outdoor cooling, of course, it's important to know a little bit about the water. So in theory, all kinds of good, clean drinking water can be used. But if you want to have a long-lasting and well-working system, it is strongly recommended to use only demineralized or reverse osmosis treated water for your spray system. And why is that? Water is a chemical mixture of different dissolved elements. It can be calcium, magnesium, sodium, nitrates, sulfates, carbonates, and so on. So whenever we drink water, it is a chemical mixture of different things. And when we evaporate the water, when we spray it out and the water, the H2O evaporates, all the elements in the water will remain and settle as dust in the area. So the less dust or the less elements we have in the water, the less dust we will have in the area where we make our cooling. Information about hardness, conductivity, contents of salts, and so on can be found in water analysis from the local water supplier. In many countries, you can look it up on the internet. If not, then you can always contact the water supplier and ask for water analysis. Within Condair, we say, as a precondition for all our humidifiers and all our evaporative cooling systems, that they have to be supplied with water of drinking water quality. And if you don't want to drink it, then you should not spray it out into the area. There might also be a few bacteria in the water. We will come back to them later on. Yes. TDS, or totally dissolved solids in water, totally dissolved salts, you can also say, is related to the electrical conductivity of the water. And why do we say this? Because electrical conductivity is easy to measure with a conductivity meter, where you simply check how good is the water to conduct current, and that is easy to measure. Conductivity is measured in microsiemens per centimeter. This is a unit. And if we know the conductivity of the water, you can also calculate and find out how much TDS, how much total dissolved solids do we have in the water by dividing the conductivity with 1.6 as a denominator. This denominator might vary slightly from place to place, depending on the composition of the water, but it can be used as a rule of thumb. If you take normal medium hard drinking water with a conductivity of 500 microsiemens per centimeter, this will have a content of around 312 milligrams per liter, or 312 grams per cubic meter of water. So this is one bag full of salt for each cubic meter of water. Whereas if we pass this water through a reverse osmosis system where we remove 98% of the TDS, or the total dissolved solids, we end up with a conductivity of around 10 microsiemens per centimeter, or around 6 grams per cubic meter of water. And what difference does that make when we talk outdoor cooling? If we have a system with a capacity of 1000 liters per hour that operates for 1500 hours per year, that would result in a dust load of 468 kilograms per year that we would spray out if we just took the ordinary water and sprayed that out. Whereas if we treat the water with a reverse osmosis system, then we will end up with around 9 kilograms of dust per year, which is a huge difference. You will see around many systems around restaurants and things like that, and if you take a closer look, you can see that a lot of systems are simply everything is gray and dusty around it, and that's not the way we want to do it. So use reverse osmosis or demineralized water if you want to spray it out and evaporate it. Yeah. Not only does it create dust when you spray it out, if you don't treat it, but it also causes clogging of nozzles and hygiene problems as well. So what we normally use or normally do is that we combine water treatment with our high pressure system. So it can be an integrated part of it, and we can even add some disinfection systems to it so that we have a cleaning in place system installed as well. So this is an important part. What other risks do we have in outdoor cooling systems? Of course, there are mechanical risks that you need to be aware of, especially if you're using high pressure systems. Then the system needs to be marked and should only be handled by trained people. There's chemical risks. You should only use listed and approved chemicals for disinfection and sanitation. And we have to observe the maximum limits for max concentration of the different chemicals in air and also in water. At Condair, we prefer to use hydrogen peroxide-based disinfectants to keep our system clean. Hydrogen peroxide has the advantage that it breaks down to water and oxygen after it has been used for its oxidation process in the system. There are some products available which are mixture of hydrogen peroxide and a little bit of silver salts that helps to improve the function or oxidation effect of hydrogen peroxide, so that we can sanitize with less liquid than if we used pure hydrogen peroxide. In the different countries around, there's different products available, but you can consult us and then we can guide you to the right products to use for this. Microbiological risks. Anywhere where water is present, bacteria is also present. In drinking water, there's national and international standards for the total amount of bacteria that is allowed to have in drinking water. In general, it is around 150 to 200 colony forming units per milliliter for the total amount of bacteria. And if we talk specifically for Legionella, then the max value is around or below 1 colony forming units per milliliter or below 1000 per liter. So this is definitely something that we have to be aware of, and the hygiene risk is one of the most critical risks that we have to focus on in outdoor cooling, because we normally talk public areas. A few facts about bacteria. Bacteria, they all need nutrients to be able to proliferate or to multiply. They can get nutrients from water, from any organic material, carbon dioxide, nitrogen, minerals, sulfur, phosphorus, and things like that. They need all of these to be able to multiply, especially if they want to do it fast or have the best conditions. So if they have good temperature, good food, then they can double quite fast. They multiply by cell division. It's an asexual function. 1 becomes 2, 2 becomes 4, and so on. So if we have one bacterium that doubles every hour under optimum conditions, then after 24 hours, we will have 16,777,216 bacteria. And of course, then it goes fast. So we do not try to make sterile systems, but it's our duty or your duty when you install a system to control the amount of bacteria in the system so that it stays down here where we are under control, so that we do not go into any exponential growth of bacteria in the system. And that can be traditional or normal bacteria that doesn't make any harm, but it could also be to prevent growth of Legionella as an example. We will focus a little bit on Legionella pneumophila because this is the one that everyone is afraid of within our business. Legionella is normally spreads in aerosols, and you can easily drink water containing a medium number of Legionella. That doesn't cause any problems because our stomach acid will kill them and control them. But if we inhale aerosols and we get this into our lungs, then there's optimum conditions for Legionella bacteria. So then it can cause Legionnaire's disease. The incubation time, if you are exposed to Legionella before you get sick, is between 2 and 10 days, and around 1.5% of all people exposed to it will die. So, and this is definitely what we are all afraid of, and this is why, at least at Condair, that we are doing our utmost to protect ourselves and the people that are in the area where we make our systems, not only for outdoor cooling, but also for normal humidification systems, for industrial and healthcare facilities and things like that. The optimum growth for Legionella is 37 degrees, and If the temperature is below 20, then they do not proliferate or they do not grow, and above 54 degrees C, they start to die. The mitigation for this is to keep the water temperature as low as possible. This is easy when we talk Northern Europe and other countries, but if we are in Middle East, where the temperature is always high, this might not be possible to do this. Legionella also requires a high content of iron in the water to be able to multiply. And how do we mitigate this? If we use reverse osmosis system together with our cooling system, then we would remove 98% of the iron content from the water, which then makes it much more difficult for Legionella to multiply, and it will take much longer time if it doesn't have access to enough iron and nutrients. Another fact is that you will never find Legionella alone in a water system. If there's Legionella, there's also a high number of other microorganisms. Legionella needs L-cysteine and some other things coming from other microorganisms to be able to proliferate or to grow. So the mitigation of this is that we have to keep our system sanitized. We work with the UV systems. We need to test the water regularly for total bacteria and to keep a good general hygiene in the system. So whatever we do to protect our systems for Legionella also helps to protect against other bacteria and vice versa. Whatever we do to keep our general hygiene high, that also helps against Legionella. Legionella also likes stagnant water, and it likes to be living in biofilm together with a lot of other bacteria. So the mitigation of this is that we use, or you should use, regular flushing and maintain a high water velocity in the pipes, avoid dead legs and things like that, and empty the tanks if stagnant water, or if the water is stagnant for more than 24 hours. At Condair, we work with a minimum flow velocity in our high pressure hoses and pipes with 0.3 meters per second, which helps a lot to keep hygiene in the system. And it makes it difficult for the bacteria to stick to the surfaces and to form biofilm where they can grow. Yes. In general, when we have a bigger system, or not only a bigger system, but if we have a misting system, it's important to create a hygiene management plan for the system, which is the best way to mitigate hygiene risks. There is different standards around the world. Water safety plans or hygiene management systems are mandatory in some countries, but not everywhere. In the US, there's a standard, or best practice standard from ASHRAE 188 2018, which also deals with Legionnaires' disease and how to prevent that. In Germany and Europe, we have VDI 6022 page 6, which also describes how to maintain hygiene in HVAC systems and in evaporative cooling systems, setting some maximum limits for bacteria and things like that. In L8, in UK, Australia, and other areas, this is mandatory. Also deals to protect people from Legionnaires' disease. And here it's mandatory that you take Legionella samples minimum once a year, and that you do a regular service on your system. Another one is ISO 22000, which could be integrated into a 9001 quality management system. But ISO 22000 is mainly for the food industry. It is recognized in more than 50 countries around the world. This is the one that we use in Denmark for our system, so we have built our hygiene management system according to that. Then there's also some building guides. CIPSA K19 and TM13 also tells you how to handle water systems in a building. But common for all of these water safety plans is that you have to ensure clear responsibility for the system, who is responsible for what, and you need to have clear instructions for service, maintenance, and disinfection of the systems. And after my opinion, maintenance plans are one of the most important steps to maintain or to ensure a safe system. Everyone can install a safe system or clean system from the beginning, but we have to make sure that the system stays safe also after 3 and 5 years. So a strong recommendation is that the system should be tested for bacteria minimum twice a year, and we should work with a maximum limit of 200 colony forming units per milliliter and stay with that. And as soon as we see any increase, then we have to disinfect and bring it down to this level again. Just to mention, colony forming units, this is a standard way of testing water. So you take 1 milliliter of water, distribute it over a petri dish with some agar, some foods that most bacteria like, and then you simply see how many bacteria multiply so many times that they form a colony big enough to be seen with the naked eye. This is the definition of 1 colony forming units per milliliter. And this is, by the way, a fingerprint from a technician. It's not from water. That's another story. Another way of testing water is to use some quick methods. At Conde, we mainly use a test kit called Bactiquant, where we sample water through a filter. We collect the bacteria on a 0.2 micron filter, and then we add a substrate, wait half an hour, and then we have an immediate result of this, which gives us the possibility to act immediately if something is wrong. You also need to keep record of your test results, so if something happens, if there's any suspicious that your system is contaminated, then you can go back and check how did it look some months ago. And always include a maintenance contract in the project. So when you are planning a new project, it should be mandatory that it goes along with a maintenance contract. Yes. Of course, there's a lot of different technology available that can be used for outdoor cooling, from small mobile misting units with separate tanks and some disk atomizers that simply evaporates the water. The challenge is to make sure that this water down here in the tank always remains clean and safe. We normally use it's the main technology for bigger outdoor cooling systems is high pressure systems, and combined with water treatment and pumps and things like that. We use stainless steel lines, nozzle bars, whatever, or it can be also high pressure hoses that can be used to distribute it. There's swiveling fans as well, or you can use also compressed air, can be used to atomize water and to spray it out. Compressed air systems has slightly higher running costs compared to high pressure. So for bigger systems, it's mainly high pressure systems that are used. For compressed air systems, you would need to have a big compressor as well. How much energy and water consumption is needed for outdoor cooling projects? That, of course, that has to do with the carbon dioxide footprint. If we take an example here from a high pressure cooling system with a max capacity of 800 liters per hour, is this a big system? No, actually not. This is a medium-sized system for some areas. If it runs 2,000 hours per year, the maximum cooling effect we will get out of this is 800 times 0.68, 444 kilowatts of cooling we get. And how much power do we need for this? For water treatment and for high pressure pumps, things like that. 4.5 kilowatts. That gives us a coefficient of performance of 120. This has to be, of course, compared to a normal COP factor for air conditioning, for traditional air conditioning, where we are talking 3 to 5 as maximum, also 5 kilowatts of cooling for 1 kilowatt of electricity that you get in. So water is an extreme effective coolant if we can get it evaporated in a controlled way and distribute it over the area. The amount of water we would need for a system for 800 kilograms per hour would be 1150. That has to do with the efficiency of the reverse osmosis system, where we normally have around 70% efficiency. 30% goes to drain, and a bit of water goes for flushing as well. So an annual consumption of energy would be 9,000 kilowatt hours, and we would need 2,300 cubic meter of water per year for this example here. But that is normally calculated from project to project. Yes. So the summary and the takeaway, 10 points to remember when you plan to design a system. Outdoor cooling should only be done in shaded areas, and you need to get climate data for the area and calculate the number of hours per year that the system will be running. You can calculate with a cooling need of around 250 watts per square meter, then you're not too far off if it's shaded. You also need to have a minimum capacity of around 75 grams per cubic meter of air in the area. And the air exchange should be in a range of 15 to 20 times per hour. That can be difficult to control. If it's an open area, then it comes automatically, because when we start evaporating water into the air, then it will automatically go out of the area because of an increase in vapor pressure. Collect information about available water quality. This is crucial as well. And use only clean RO water, reverse osmosis treated water, or demineralized water to ensure a well-working and a long-lasting safe system, where you do not get problems with dust and things like that. Do not compromise on safety and quality when choosing your supplier for your system. Always include a maintenance contract to ensure proper hygiene and functions. And last but not least, together with the clients, create a water management plan for the project, including disinfection, schedule for maintenance, and measurements for bacteria. So my recommendation is that either do it right or don't do it. That's our philosophy at Condair. So now that was actually it. We are coming to the questions, and just for information, the picture here on the right is from Medina, from the big mosque there. There was a project that we did together with a German company called Liebherr back in 2010. where we can, it is actually the biggest outdoor cooling system in the world. We can spray out 50 cubic meter of water, 50,000 liter of water every hour, and cool down the temperature with around 10 degrees over an area of around 14 hectares there. Thank you for your attention. And now, Peter, it's did you get any questions coming in?
Well, Leo, thank you for your really detailed presentation. I hope you hit a lot of interesting points to the audience. Basically, when I look to the questionnaire or the questions coming in, was quite a plenty. So to all now listening, please excuse if we cannot answer all your questions because we have quite a high number of participants, and sometimes I'm just flooded with questions. I try to answer them straight away. There are definitely many of the questions focusing on hygiene, and in various ways, but at the end of the day, it does touch the hygiene
Mm,
of our system, or the hygiene level we
yeah.
are offering.
Yes.
Um,
Yeah.
Basically, before I get to two questions, let's say our hygiene system inbuilt is definitely offering one of the highest quality hygiene systems the market can offer. But nevertheless, we should not forget about, even with a high hygiene level inbuilt in the system, it does not prevent that the owner or the operator is definitely doing the necessary maintenance as well during the operation time of the unit. So we can cover a big range of hygiene, but it's always teamwork as well. The operator has to give his share to keep the system in a nice way running. Let me look now at one of the questions, which is oh, I have so many red flags, it's unbelievable. Yeah, one of these came in. What precautions are necessary on restarting the system after a prolonged period of shutdown, such as the winter period when cooling is not required?
Yeah. Yeah. That is what we normally do, and what we normally recommend is that we say if a system has been stagnant or shut down for more than 48 hours, then we say that it needs to be disinfected before we restart again. That's the general advice that we have. So a normal standard disinfection, and then followed up by a water test, and then it's safe to operate the system again if the bacterial counts are fine. And what you do when you want to, if you want to shut it down for a longer period, the last thing you do is that you fill it up with disinfection liquid, or the, as in the concentration, we call it preservation, so that we make sure that we have disinfectants in the water standing in the time when it's not in use, and then drain the tanks and water treatment as much as possible, and then it's, yeah, then it's safe again when it's restarted.
Okay, then there is another question. I'm not sure whether this really concerns the hygiene. Maybe I misinterpret the question. Jack is asking, can you use this for decontamination with disinfectant in the water?
Mm, uh,
I get the
this
point
is,
now.
yeah, I know what he means with it. As a, can an outdoor cooling system be used to disinfect the area,
Exactly.
or to disinfect the room? Theoretically, yes, but we definitely do not recommend this. We have the same situation in industrial applications, where people would like to use the normal humidification system also to disinfect the rooms. but we say no. Keep it separate. Install a separate system for disinfection to avoid the risk that we have that if someone starts the system and it's filled up with chemicals and we spray it out when there's people in the room or in the area, then we really have to be careful not to exceed the maximum values for the different chemicals in the air.
Good. Another point which is definitely important, there are still questions popping off. We try to get back to them after we close the webinar. One point is as well several times mentioned, what about the wind impact when using this outdoor cooling system? What can we do? What is possible? Yeah, what is there a full solution about it, or how is our point of view here?
No, and it's the same for everyone, no matter which supplier or which technology is used. If there's winds, then the cooling effect will be blown away. So that's difficult. The only way to keep the cooling effects in the area is to make sure that the wind velocity is not too high. So there's no easy tricks here to make sure that we can maintain the cooling when we are evaporating water.
Yeah. So wind is always something we cannot predict. No. And we have to take this risk. All of us have to take this risk. We cannot say and give you a 100% clear answer on that. Basically, it's a nature impact, and we don't have a direct solution for it. But you have to keep it in mind, and we always mentioned when we are talking about the project that the wind is definitely a point which we cannot influence, but we have to consider it. Last, we are now close to end of the webinar. I just want to offer one other information. Many questions came in about indoor-outdoor cooling for this system. Now, let's put it straight here. We were offering an outdoor cooling system. And of course, indoor cooling is as well. It depends on the project. It depends on the location. Is it duct? Is it direct room? We have several systems available which we can use in duct, direct in the rooms, and we have to look at it always in detail because the site, the parameters, the windows, whatever is in, we have to consider and make you the right offer, or offer you the right system for your needs. So here we were talking clearly about outdoor cooling. Indoor cooling, we have definitely the point that the air might be catched up in the room, so you have to have a good air exchange, otherwise your RH will go above the normal and acceptable comfort zone level. So we are happy to offer you all the information you need. Just get back to us. We will either answer directly or we'll forward it to our responsible or specialist responsible in your area. So don't worry, we are absolutely happy to answer all the different questions. But for today, I have to close here, even there are still questions coming in. Some very detailed, which we are not able to answer them straight away during the webinar now here.
But
so,
Peter,
yeah.
I could just add one comment here concerning indoor cooling. Of course, the theory is exactly the same, and this is what we do quite often in industries where the heat load is not coming from the sun, but coming from processes that we have inside an industrial building, from machinery, from processes and things like that. And there we also make evaporative cooling systems, install humidifiers or coolers, whatever you call it, to absorb this energy. And it's actually easier to do it indoor compared to outdoor, because indoor there we have a controlled ventilation system, so that we know how many air exchanges do we have, and we have a constant heat load normally. So that's easier. So it's definitely possible, and it's something that we do not every day, but very often that we install these.
Whether it's outdoor cooling, indoor cooling, direct, indirect, we have a solution for it. Just get back to us or contact your local partner, Condair partner. Then we are definitely able to provide you all the answers on your questions and to offer you the necessary support to take the right decision. So we are at the end of our today's webinar. Thank you for your attention. And all contacts are you have seen, and you will again, just a little reminder, approx 1 hour after this webinar, you will get the certificate of attendance, and there you will get as well a link to the recording, to the videotape, so you can study it in a quiet moment and get back to us with further questions. Thank you very much for your interest. Thank you very much for attending, and we are happy to be in contact in the future. Just don't bother, get back to us, and we will answer your questions in an ideal and best possible way. Thank you very much, and goodbye.
Yeah. Thank you from my side as well, and goodbye.